fairly sensitive to not doing that uniformity correction. This is, normally if they just do like a uniformity flood, it's real obvious, but this one, can you all see that? So anytime they talk about ring artifact, that's what they're talking about. Okay, so where are we at? Number 8. This is the one I was talking about before. You're doing an uptake on the patient. Thyroid counts at 5 centimeters from the surface of the patient neck. Standard at 20 centimeters from the neck fan. Okay, what's going to be the effect? Why would it be increased?
Well, it's closer, so it's collecting more counts than the geometry was wrong. So there's going to be more counts at that distance from the thyroid.
Yeah. Remember the inverse square law. The closer you are to a radiation source, the higher the intensity. So it's going to be higher here, and then it's going to be how much? Let's say that we have the same number of counts in the thyroid as we have in the fin. So it's 4 times the distance away. So how much of a reduction? In this case, 16 times less. Yeah, this stuff all kind of comes together after a while. Sort of?
Yes. Big picture.
It makes more sense now than before.
Oh yeah, definitely.
Okay, here you are working with F18, and you need to order a syringe. One vendor sells 5.2 millimeters of tungsten. I don't think anybody would use 5.2. Most of the time they're like about 14 millimeters. But anyway, so you have 5.2. Half-value layer of tungsten is 2.6. What fraction is the dose going to be reduced if using the shield as compared to no shield?
Is it 2?
2?
No,
Half-value layers. How many half-value layers are there?
there's 2 half-value.
So 50, see?
So one would reduce it by half, 2 would reduce half by another half, which is
75.
No?
25%. Just 1/4.
How come half of 5.2 is 2.6?
0.5 squared.
So once it goes through once, it's going to be 50%. Goes through again. It's going to bring it down. Well, it's going to attenuate 75%, so 25 goes through.
Yeah, well, the question is saying, okay, 2.6 is 1 half-value layer.
Mm-hmm.
So that means that if you had 100 photons over here, and you're going to have 50 over here, right? And if I have another half-value layer, because it says you had 5.2 millimeters, and 5.2 divided by 2.6 is equal to 2,
Mm-hmm.
so you have 2 half-value layers.
Mm-hmm.
So if I have 50 go through this half-value layer, it's going to be 25, right?
Right.
Okay. So it's going to reduce it by a factor of 0.25. Okay. I like that how it frames there. Okay, so number 45, the answer is B. Okay. The patient is sitting in their wheelchair when they're administered MAA. Therefore,
B.
okay, yeah, the apex will concentrate less. So remember, you want the patient breathing, and you want to inject slowly when you do MAA. Most people don't remember that, they just inject it regardless. Okay, 47. You have a renogram on a transplant patient. To do this study, the technologist would do what? Miss Ashley, what would you do?
Yeah, D. Because transplant is more anterior.
47. letter D then. Do the reading gram with the anterior protocol. Okay, very good. I'll put Mr. Singh on the spot for the next one here. Oh, Mr. Singh. You ever seen this before?
No.
Has anyone seen this before?
Uh-oh.
SMPTE Phantom. All of your computers, computer monitors, any type of your digital printing devices, your laser printers, they have to do this. It's a test pattern that allows us to see contrast. Now contrast is black and white, and up here we have white and black. Here we have the scale of contrast. And then in each corner, you can't see over here in the corner, but they have these resolution patterns. These resolution patterns, what do we measure resolution in, by the way?
Line
Line
Okay, line pairs per millimeter.
Yeah.
Okay, a line pair is usually like with a phantom that we use for nuclear medicine each week. It's one lead and one plastic strip. That's one line pair. Okay? So basically this one has black, white, there's one line pair, black, white, there's two line pairs. Normally these resolution phantoms are up in the corners too, that you can't see them on this one here. Then we also have low contrast phantoms here. So we want to be able to see high contrast, low contrast, all the different scales of grays and things like that. So, who can tell me what the SMPTE phantom is, or what it stands for? Mr. Singh.
Okay, I don't know.
And Mr. Andy.
Never use it before.
Okay, well you should get familiar with it because this is a test that you have to do for your computer monitors to make sure that you can read films.
Even printers have this, right?
Yeah,
Like regular printers.
yeah. Actually, I don't know if you guys can see it, I've got it here, actually. I did one just for the heck of it, I think. Usually on a great big sheet of film.